Okay, Bismillah. Okay, folks, welcome back to our GCSE class. We are looking at some further questions on probability tree diagrams. So, which is your first question? What does it look like?
Tara has 8 balls in a box.
That one. Found it. Okay, here we go. Let's try recording here. Okay, Tara has 8 balls in the box. 5 of the balls are blue. Okay, 3 of the balls are red. Tara takes a random ball from the box and writes down its color. Tara puts the balls back in the box. So this question here, because she puts the balls back into the box, the second level of fraction, will they change or will it be the same? It will be the same. So this is called with, oh, not really fancy today. With my mask on. It's called with replacement, because it puts them back in. When Tara takes a random second ball from the box and writes down its color, complete the probability tree diagram. So how many balls are there altogether? There are 8. So the fraction is going to be out of 8. So probability of getting a blue ball is how many? 5 out of 8. And the red one is 3 out of 8. Now if we go to the second level now, the probability is going to be exactly the same. 5 eighths and 3 eighths. Okay, the probability doesn't change because we are putting the ball back in. Okay, so that's worth 2 marks. Okay, Mr. Hassan, have you got one of the classwork sets in front of you?
I got one. I just got one.
That's the one there. That's the thing. Yeah. If you need to turn it, open it, rather than having upside down the that's blank page. Okay. Right. Because work out the probability that Tara takes exactly 1 ball of each color from the box. Right, now I need someone to interpret that for me, because it actually can be misinterpreted as this something completely different. So anybody want to have a go at explaining to the class what that means?
Is it the probability of getting a blue and a red, or a red and a blue?
Okay, good, lovely. Work out the probability that Tara takes exactly 1 ball of each color. So 1 ball of each color means that means she gets blue first, followed by a red, because that's 1 blue, 1 red, so 1 of each color. Now, or she could actually get a red first and then a blue. So we're looking at probability of blue and the probability of a red. So that can get translated into 5 eighths multiplied by 3 eighths. If you see me write the wrong number, please folks tell me straight away, yes? Okay? Or if you look at the red and blue, so I'm writing down my kind of idea, probability of red and the probability of blue, which is equal to 3 eighths times by 5 eighths. Are we happy with that so far?
Yeah.
Now, as Rutaba mentioned earlier, yeah? You did mention the word was keyword. Keyword was or. And the or means for us, what does it mean? So once we worked out these answers, the or means that we have to add them. Because we got these 2 combinations that could give us the possible answer. So what's 5 eighths times by 3 eighths? That will give you at the moment 15 out of 64. And the next one will give us what? 15 out of 15 out of 64, and 15 out of 64 gives us what? 30 out of 64. We don't ever add the bottom numbers in a fraction. So that will give us 30 over 64. Okay. The sheets are in front of you. 30 out of 64. Done. Are we happy with that? We can cancel that down as well if you like. Okay, so we got 30 out of 64. Who's cancelled that down? So what should we divide it by?
2.
Divided by 2. Okay. So that will give us what? That gives 15 over
32.
32. Can we cancel that any further? No. Can we leave it at that then? Okay, that's the answer to that. Another examination question, but it involves understanding the question wording. Okay, lovely. Right, let's move on to our next question. Let's move on to our next question. Okay, Mr. Yes, okay, lovely.
You just do Prob.
Yeah, I've just done part B and part of it. I'll come these on the screen for a few more moments while the stragglers who've just come in they can copy it up, please. Right. Everybody have a quick copy that up. Have you copied it? Done it, Mr. Hassan? Copying is his middle name, eh? He loves that word, eh? Wait for Sir to finish and then that's it. Knocks it all down. All down the hatch.
Nah, don't do that stuff.
No, you don't know that. Okay. Active record mode forces next question. In the game of chess, a player can either win, draw, or lose. The probability that Sophie wins any game of chess is 0.5. The probability that Sophie draws any game is 0.2. And Sophie plays 2 games of chess. Okay, so these events are, what do you call them? Independent. Okay, Mr. Hassan. So the second layer of value is the same as the first layer, don't change. So we have 0.5. Okay, let's change. Let's change this for a second. There we go. Right. 0.5, 0.2. What's left over now from 1? 0.3. Altogether, it must add up to 1 point. Oh, it's supposed to be. Oh, pardon me. Oh. 0.3. Okay. Right. So what should we fill in here then? Should we quickly fill this in? So this that's going to also be 0.5, and that's going to be 0.2, and that's going to be 0.3. Okay, I'm just going to change color here so it doesn't get too confusing. 0.5, 0.3, 0.2. Change color again.
It's 0.2 and 0.2.
Sorry, thank you. Straight away, that's lovely. Spotted it straight away. Somebody's awake. Okay, that one should be, what is it? 0. Okay, good. 0.2. And that one should be 0.3. Okay, lovely. Right. And the next one should be 0.5, 0.2, 0.3. Okay, now the question says this. So we fill in the tree diagram. So we've got how many marks for that, Mr. Haroon? 2 marks. Work out the probability that Sophie will win both games. So we need to look at the probability of winning both games. So we can have a win and a win. So that's called probability of a win and the probability of a win. So that's going to be the first probability, which is 0.5 times by 0.5 multiplied by 0.5 will give us an answer of 0.25. Okay, that's question B. Okay, there's one more question on the paper, right? Actually,
Right, that's right to start.
at the start, isn't it? Can you find that question there, please?
There are 3 messages.
Here comes the last question on the revision of probability. There are 3 red sweets, 2 purple sweets, and 5 orange sweets in a bag. This is an examination question. Georgina takes a sweet at random. She eats the sweet. Lucky her. She then takes another sweet at random. Work out the probability that both the sweets are the same color. Now, the key word here, let's get our brush ready. Brush, size, medium. Okay, has anybody spotted the key word? The key word is she eats. Now, if you've eaten something, that means you haven't replaced it. Obviously, it's gone down your belly. You haven't put it back in the bag. Unless you're doing some kind of vomiting afterwards or something, some kind of mad stuff. Okay, so we know this question is going to be a question which is going to be without replacement. If I can spell it properly. Without replacement. Okay, so now we got which one? Red, purple, and orange, yeah? Okay. So should we draw ourselves a little tree diagram, yes? Okay, here we go. So how many possibilities we have first of all? So we have probability of a red, probability of a purple, and probability of an orange. Is that right? As our first choice. Now the second choice. Oh, I don't want to use black again. 1, 2, 3. I'm just going to have to kind of improvise a bit. And okay. And then we have red again. And purple, orange, red, purple, orange, red, whoops, purple, and orange. Now, to tell you the truth, because we need to only work out both the same color, we really need to kind of be considered with what. So I'm just going to go over it. We're going to consider the red followed by red, that path. And then we also need to be considered with, okay, let's change color now, purple. Purple followed by purple. Then we're going to need to be considered with, actually, it would be nice if we actually done red. Red. Red with red. And then we're going to have orange with orange. And let's put the probabilities on so for those questions now so far. Okay, what color are we going to choose? I don't know. So probability of red was what? How many we had red sheets was there? 3 out of
10.
That's right. If you add them all up, 3 add 2 is 5 is 10. So that's going to be 3 out of 10. And the purple was what? 2 out of 10. And the bottom one was
5 out of 10.
5 out of 10. Can we see that green? Is that coming up on the screen? Can you see it, Mr. Hassan, was a bit light? Shall I go over in different colour?
It's a bit light.
It's a bit light. I'll go in just in black. Can we see that now better?
Yeah.
3 out of 10. 2 out of 10. I have to go over it. And 5 out of 10. Okay, now, we've eaten one of the red sweets she has. So the next red is going to be how many, Hassan? 2 out of 9. Because one sweet has been eaten. That's right. So now you've eaten the purple one first, 2 out of 10. So the next one's going to be 1 out of 1 out of 9. Because you started back from the beginning again. So 5 out of 10 first, then it's going to be 4 out of 9. Lovely. So we now begin to build up our little picture here. So what we're going to do, it's going to be either the probability of a red and the probability of a red, which is equal to 3/10 times by 2/9. Or it's going to be probability of a purple and the probability of a purple, which is equal to 2/10 times by 1/9. Okay. Or it's going to be the probability of an orange and the probability of an orange, which will be 5 over 10 times by 4 over 9. Let's start working these out now for me, please, folks. So that'll give you 6 over 90. That'll give you 2 over. That'll give you 20 over. Okay, now, the key word we used here was or. The word or means add. So add. Let's try squeezing the bottom. 6 90ths, add 2 90ths, add 20 90ths. That'll give us what? 28 over 90. Can we cancel that down? What do we get?
14 over 45.
14 over 45. Can that be cancelled any further, Taba? And that's the end of our probability section. For now, we'll add this to the playlist on YouTube. Okay, did any of you guys look at that from last week? Okay, no, I've got your homework from last week. It's in your book. That's, okay. Okay, that's the end of that video. Okay, folks, thank you very much for joining us.